There has been a lot of anticipation today around NASA's first ever attempt to strike an asteroid and knock it off course. William Brangham has all the details.
Judy, NASA today pulled off a historic first. Take a look at this.
Oh my gosh.
Oh, wow. Awaiting visual confirmation.
This is video received just a few moments ago of the exact moment when NASA's DART spacecraft approached and then crashed into that asteroid 100 million miles away. We'll talk with science correspondent Miles O'Brien in just a moment. But first, here's his report on exactly what NASA was attempting with this mission.
Planet Earth is practicing defense, David and Goliath style. A spacecraft the size of a vending machine is hurtling toward a kamikaze dive into an asteroid the size of a Great Pyramid.
DART is the biggest engineer's dream ever.
Elena Adams is the systems engineer for the Double Asteroid Redirection Test, or DART. It's a $330 million NASA mission designed at the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland.
And liftoff.
Launched in November of 2021, DART is nearing the end of a 107 million mile journey to the asteroid Didymos.
Our job is to go hit an asteroid, and that's a very specific job for planetary defense.
Their target is actually the asteroid's moon, Dimorphos. DART is programmed to auger in at 14,000 miles an hour. Engineers hope the 1,300-pound spacecraft will nudge the 5 billion-ton Dimorphos into a new orbit. Dimorphos is not headed toward Earth. It's just a test.
This is the first time in human history that we've actually set out to change the orbit of a natural object in space.
Lindley Johnson is NASA's planetary defense officer.
The orbit of an object is determined by the velocity at which it is orbiting. So if you just shave a hair, less than 1% off of that speed, you've changed the orbit and, forever altered where that object will be in space in the future.
Our planet gets grazed and hit by asteroids all the time. Most offer harmless thrills for stargazers, but the bigger ones are a different story. In 2013, a 60-foot asteroid exploded about 100,000 feet over Chelyabinsk, Russia. About 1,500 were injured by shattering glass. Over the epochs, much bigger asteroids have triggered mass extinctions, including, most infamously, the dinosaurs 65 million years ago. Planetary scientist Nancy Chabot is coordination lead for DART. Is it accurate to say it's inevitable over the course of time that there will be some rock of relatively big size, which has our number on it?
So this is going to continue in the future. It is sort of a cosmic, inevitability at this point. The good news is, of the asteroids that we're tracking, there are no known threats, right? But this is also why we need to find all these asteroids and figure out where they are.
In 2005, Congress directed NASA to find 90% of potentially hazardous near-Earth objects 460 feet or larger by the end of 2020. So far, ground-based surveys have found all the planet killers they can see, but only about 40% of the asteroids big enough to wipe out a city. At this rate, it would take 30 years to approach the finish line. But no matter how hard they try, they will never cross it using only ground-based telescopes.
So there's a whole half of the sky we're not looking at because basically the glare of the sun prevents you from looking there very easily.
Astronomer Scott Shepard is a senior research scientist at the Carnegie Institution for Science.
The ones that are most concerning are the ones that spend almost all their time in the daylight, that just get up to where Earth's orbit is or just barely cross it. So the vast majority of their time is in the daylight.
Shepard is using the National Science Foundation's Blanco telescope in Chile to look for the holy grail of astronomy, Planet X. He decided to point the lens toward the sun at twilight to see if he could see any near-Earth objects.
It is a hard thing to do.
So when you looked, you saw some objects that are hiding in broad daylight.
We found several near-Earth objects in this survey now that have not been found from other surveys, and they're fairly large objects. These are planet killers.
So it's possible in this scenario we could have only days to act? Is that possible?
We're really not monitoring the daylight side of the Earth very well. And so if something's approaching us from that distance, it would be very hard to find it. And most likely, it might even hit us without us even seeing it.
A DART-style mission would have to impact years in advance to knock an asteroid off a collision course with Earth. Astronomers say the solution is a space telescope called NEO-Surveyor. It is designed to orbit between the Earth and Sun using a wide-field infrared camera to identify potential threats that we can't see on Earth. Congress may have mandated NASA find the most hazardous near-Earth objects, but it did not appropriate specific funding. And so the billion-dollar mission is floundering. The Biden administration just delayed it 2 more years.
It all comes into the priorities of what NASA has on its plate. It has more things that it's been asked to do than the funding that's been appropriated.
Shouldn't we be spending money on surveying before we practice changing the orbit of an asteroid?
Well, you know, certainly you got to find them first.
But the orbit of Didymos and Dimorphos brought them close enough to Earth to create this target of opportunity now. It is a complex technical challenge. The target is only about 525 feet across, too small for the spacecraft to see until the last minutes. When are you going to see it?
Well, we don't know. Maybe as early as 80 minutes prior to hitting it, or maybe as late as 35 minutes before we impact.
So this entire journey comes down to really, in 35 to 80 minutes time, this spacecraft has to identify this tiny little rock and hit it right where you want.
Yes.
What could go wrong with that?
Oh, nothing. Nothing whatsoever. It's going to be great.
The spacecraft is equipped with a powerful camera, smart software, and advanced avionics able to autonomously identify and home in on Didymos and then switch to Dimorphos once it comes into view. Dimorphos orbits Didymos roughly every 12 hours. Team DART hopes to speed it up by at least 73 seconds. To see if it works, astronomers will point a few dozen telescopes on every continent and in space at the asteroid. Planetary astronomer Andy Rivkin is a lead investigator. Newtonian physics would tell you that this is going to perturb this rock.
Absolutely.
So what do we have to understand further at this point?
We do expect to make a lot of ejecta, as we call it, when DART hits. That also is carrying momentum. How much bang for the buck are we going to get?
And we can watch the bang as it happens. DART is designed to transmit live images of its death dive. Must-see TV. Ask any dinosaur. For the PBS NewsHour, I'm Miles O'Brien in Laurel, Maryland.
And Miles O'Brien joins me now. Miles, this is just such a tremendous accomplishment for NASA to have pulled this off. And seeing that self-evident joy in that mission control room tonight, I wonder if you could just, for a moment, reflect on this accomplishment today.
Yeah, William, I found it rather emotional. First of all, it's pretty rare when you see a crew of engineers and scientists involved in space applauding a crash. All right, that's number one. But number two, this is a pivotal moment in human history. We are now at a point where we know we could do something if we were in the crosshairs of a big rock. You know, talking to these scientists and engineers, they say, you know, getting on an airplane and people asking them what they do, they have some esoteric endeavor that they're studying in space, and people's eyes kind of glaze over. When they tell them they're involved in this mission, they have people's attention. So there is a particular level of pride here, because what they're doing, it's very difficult to think of a more important mission in space than this one.
Indeed. As you laid out in your report, the mission here, the idea is this crash diverts this asteroid just a tiny bit to alter its orbit. How will they know whether or not that part of the mission has succeeded?
Yeah, well, that's going to take a little bit of time. Telescopes will be aiming at it, all the continents, a couple of space telescopes as well. And the reason they chose this binary system is the little object that was hit, Dimorphos, orbits around the larger object, which we can see from Earth, about every 12 hours now. When it does do that, though, when it passes in front, it dims ever so slightly, kind of like a mosquito on a headlight, I suppose, but it still dims, and the telescopes are sensitive enough to register this. When it dims, they hit a stopwatch, and then when it dims again, they hit the stopwatch again. As long as that orbit is faster than it was before, by 73 seconds or more, they have succeeded. It's going to take a little bit of time to crunch these numbers.
Let's say that this as you laid out, this was an experiment. This asteroid was not a threat. But let's say there was an asteroid that was a threat, and they aimed a DART-like mission and it missed. What do we do in that case? I mean, I seem to remember that hokey Bruce Willis movie where they sent oil drillers to an asteroid to try to somehow disable that. Are there other options in addition to this kind of mission?
As an asteroid like this gets closer, you run out of options pretty quickly. And while the Bruce Willis movie is highly entertaining, you would never drill into an asteroid and put a nuclear bomb inside it. However, a lot of scientists have been looking at exploding a nuclear bomb offset from the object so you don't blow it to smithereens, which is a bad idea. And you could jar it off course significantly enough in time potentially. Let's hope, though, we just survey the skies so we're not in this situation. It's worth the money, I think.
Miles, lastly, in just a few seconds we have left, I've shot a little bit of pool. This seems like a bit of a bank shot, and we know those pool balls act in predictable ways. But asteroids are not always made of the same kind of material.
Yeah, we know the physics. We know it's going to move it at some level. The question is, when that plume comes out, the ejecta comes out, what will that do to move it further? It actually creates a little additional boost, a little momentum to it. And that's the key thing the scientists are interested in here, how much bang for the buck they can get.
Miles O'Brien, thank you so much.
You're welcome, William.